In this video, I'll be discussing about the nature of roots of quadratic equations. For example, we have a general form of quadratic equation which is of the form ax square plus bx plus c equal to 0. Like, in order to comment about the roots of this quadratic equation without actually solving it, we have to find its discriminant, and discriminant is equal to b square minus 4ac, and you can also write discriminant by letter d. Now whatever the value of this b square minus 4ac comes up, value of t can be greater than 0, value of t can be equal to 0, or value of t can be less than 0. So if the value of t comes up greater than 0, then we have real and unequal roots. And if the value of t comes up equal to 0, then we have real and equal roots. And if the value of t is less than 0, then we have unreal roots. Or it's better to write no real roots. No real roots, or we can say complex roots. Now we will take an example. For example, we have a quadratic equation x squared plus 6x plus 9 equal to 0. Now we find the value of its discriminant, and it is equal to d is equal to b squared minus 4ac. Now if I compare this quadratic equation with general quadratic equation, then the value of b comes up equal to 6, a is equal to 1, and c is equal to 9. And I put the values of a, b, and c in this quadratic equation in this formula. So it's equal to 6 square minus 4 times a is 1 times c is 9. So it's 36 minus 36 is equal to 0. So value of t comes up equal to 0. So now, without actually solving this equation, we can comment about the nature of its roots. We can say that this equation has real and equal roots. Now you can verify this process by actually solving the equation. For example, when we will actually solve this equation by the method of factorization, or by completing square, or by quadratic formula, then you will see that you will get x equal to minus 3 here. So both of these values are equal and they are real. So here we have real and equal roots. When you will actually solve this equation, you will get x equal to minus 3, and these values are real and these are equal. Now let's take another example. For example, we have equation which is of the form x squared plus 4x plus 8 equal to 0. Now we want to comment about the nature of its roots. We find the value of its discriminant, which is t is equal to b square minus 4ac. Now if we compare this quadratic equation by a general form, we get a is equal to 1, b equal to 4, and c is equal to 8. Now I put these values in this formula. I get 4 square minus 4 times 1 times 8 is 16 minus 32 is equal to minus 16. Now the value of t here comes up less than 0. So we say that this equation has no real roots. We can comment about the nature of its roots, and that is no real roots here. Now if you want to verify this process, try to solve this equation in real, and when you will try to solve it, you will get something negative here, something negative, like some number here. You will get something negative in the square root. If you get something negative in the square root, then we write no real roots. And when you will try to solve this equation, you will get something like that. So without actually solving the equation, we can comment directly on the nature of its roots. Let's take one more example where we have something like 5x plus 6 is equal to 0. Now we repeat the same process. Value of a here is 1, b is 5, and c is equal to 6 here. Now I find the discriminant of this quadratic equation. It's d is equal to b square minus 4ac, and this is 5 square minus 4 times 1 times 6 is equal to 25 minus 24 is equal to 1. Now the discriminant here is greater than 0. Therefore the roots of this quadratic equation are real and unequal. Now when you will try to solve this quadratic equation, you will get the values of, we can solve something like x squared plus 3x plus 2x plus 6 is equal to 0. And if you want to learn how to solve this quadratic equation, how to solve any given quadratic equation by different methods, then just watch my previous videos. So it becomes x, we take x common from here, plus 3 plus 2 x plus 3 equal to 0. So here we get x plus 2 times x plus 3 equal to 0. Here we get x equal to minus 2, x equal to minus 3 here. So we can see that x equal to minus 2 and x is equal to minus 3 are real, but they are unequal. So without actually solving this quadratic equation, we can comment about its roots. So that's all about this video. We learned how to comment on the nature of roots of given quadratic equation without actually solving it. See you guys in the next video.